I'll explain what is the meaning of equipotential. It is the imaginary surface around the charge configuration where potential is same. It is the imaginary surface. It is the imaginary surface around the charge configuration where potential is same. Let us consider this same thing. Yes, our main hero. What's the name of our hero? What's the name of our hero? Yes, Rocky Boy with KGF with electric field. Yes, with electric field. KGF with electric field. Rocky Boy with electric field. Now what? Now what? Yes, this is our electric field. If I draw a circle here, an imaginary circle here, and if I check potential here, potential here, potential here, potential here, potential here, the potential everywhere will be what? That potential everywhere will be same, and this is known as equipotential surface. Are why same? Why not to be same? See, we have formula. What formula we have? We have derived the formula. This formula. We have derived that we have V is equal to KQ over R. Yes, if you want, you can consider this as our Rocky bike. That is Q. Okay. So our K is constant. Yes. Our Q is constant. Yes. Rocky bike is constant. So V is inversely proportional to R. See, in this circle, R is not changing. R is constant everywhere. If R is constant, so what will be the problem to V? We will say, I don't have any problem. Let the voltage same everywhere. Okay. Once more, once more, once more. Let's see. Let's see it once more. Let's see it once more. What we have Rocky Bhai, we have KGF, we have we have a circle. Then what? Then what? Yes, where potential will be same, potential will be same here, potential will be same here, potential will be same here, potential will be same here. Why potential will be same there? Because V is equal to KQ over R. K is constant, Q is constant, K is constant, Q is constant. That means V is inversely proportional to what? R. Here R is not changing, hence this is what? This is our equipotential surface. Okay? Achha. Now say, if I draw one more circle, if I draw one more circle which is bigger than this one, so same here also, our field will be same here, 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 and here. Electric fields will be same now. Yes, same. Why? Because it depends on R, and here R is not changing. 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 It is changing? No, it's not changing. That means what? If inside it is 5 volt, here it will be what? It will be what? It will be 2 volt. Or why it will be 2 volt? See, V is inversely proportional to R. As R is increasing, our voltage will drop. As R is increasing, see, from here to here, R have something value. From here to here, R will be greater. Na? If R is greater, V will be what? V will be smaller. Hence, here the value of V will be smaller, and here, sorry, here V value of V will be greater, and here the value of V will be smaller. Okay, so I will give you some points. The first point is, just keep this thing in your mind. See, I'll explain you once again. Here, here, and here. Our potential will be same, right? Why? Because radius is not changing. But if I talk about this point, 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 our potential will be same. Yes, the potential will be same. But where there will be the higher potential will be inside. If this is 10 volt, there will be a reduction, and there here it will be what? It will be 8 volt. Why it is happening? Because our V is inversely proportional to R. V is inversely proportional to R. As radius is increasing, our V will be what? Our V will be dropped. If it is 8, if it is 10 first, then it will be 8. After that, it will be 5. After that, it will be 4. And there will be a region at infinity. At infinity, our voltage will be equal to what? That will be equal to 0. Color, understand? We'll move to further. Yes, we'll give you some points just to see this point. The first thing, at the surface, our potential will be what? Our potential will be same. Then what? Then surface always remain perpendicular to electric field. Surface is always perpendicular to electric field. To electric field. Third, always in the direction of electric field, always in the direction electric field decreases. Always in the direction of R, electric field is decreasing. Same this thing. Always in the direction of R, electric field is decreasing. As R is increasing, V is decreasing. Okay. And the third thing, this surface can't intersect. They can't cut each other. Surface can't intersect. If this would intersect, the value of this and this would be same because it depends on the R. Therefore, this surface can't intersect with each other. Okay. Now we'll move to the next one. So what is the equipotential surface? Equipotential surface is the surface that has same potential at every point due to charge distribution. Due to charge distribution. Okay. First question आपके स्क्रीन के ऊपर ये रहा. First question of equipotential surface is a surface where the electrostatic potential is same at every point is referred to as what? Anyone? We have less time. Anyone? Be fast. A surface where electrostatic potential is same. A surface where electrostatic potential is same is known as what? Next time I would hide this options also. Yes, in the comment section, everyone. Yes. Yes, Badul. Answer is yes. Answer is D. What is D? Equipotential surface. Only 5 answer. Equipotential surface. But yeah, every 5 answers were correct. It's very good.